Hello, in this video I'm just going to go through an OCR A-level question, which is pretty straightforward, but I've been asked a question about part 3, and the important thing is about part 3 is you can't do it whichever way you'd like to, because what most people would want to do is the standard thing where you find in d2y by dx squared the second differential to work out whether it's a maximum or minimum. It actually asks you to use the graph you've done before, which is why I'm doing this question, because it's a little bit unusual. First two bits is quite standard. You've got a curve which has equation a quarter x to the 4 minus x cubed minus 2x squared, and you're differentiating that, so that's pretty straightforward. Take 1 off the power and times by that number, so that's x to the cubed. Might take times by the number in front, take 1 off the power, x squared, and take 1 off the power times by that number, that's 4x. So that's pretty straightforward. And then the next bit is to sketch that gradient function. So you're basically sketching this cubic here. So all you have to do is factorize that, and it's a standard cubic thing, really, factorizing that. We've got that becomes x plus 1, x minus 4. So we can readily draw the curve. It's going to go through minus 1. It's a positive cubic, so it's doing that. It's going to go through minus 1, 0, and 4. So that's not really the thing that's caused any issues here. But as I say, it's the third part that has raised a few questions. It says, by considering the x-intercept of the graph drawn, so it's basically by considering these x-intercepts here, determine the coordinates of the maximum. Well, thinking about it, the gradient of a curve, if the gradient of the curve is decreasing, and in particular if it goes from positive to negative, it's a maximum, and that's the only time that happens. So for example, the x-intercept here, although it's 0, so you've got a turning point, it's increasing and it's going from negative to positive. So there, that would represent a minimum. This one would represent a maximum, and this one would represent a minimum. So you could say you need to justify the fact that you're looking at this graph rather than just telling the examiner what the answer is. So you could say various things. One thing you could say is at x equals to 0, gradient equal to 0, or dy by dx equals 0 even, and is decreasing. Going from positive to negative. And we can see that as we look at it. If you look at this, how a maximum looks, we can see the gradient decreases. It's 0 here, and it decreases gradually along the way, goes from positive to negative. Okay, so the gradient goes from positive to negative. So therefore, so long as the examiner is convinced you know what how this graph, because it's going, the gradient is going from positive to negative, the gradient function is decreasing. So gradient function decreasing, you've basically answered the question. So this is one of the ones where it's easy enough to actually find where the maximum is. You differentiate and you can equate to 0 and find a second differential will be the standard thing to do. But in this case, because they asked the graph, you need to explain how the graph shows that 0, 0 is a maximum. It's all to do with the gradient function being equal to 0. and the gradient function being decreasing, going from positive to negative at the point where x equals 0. So that's the answer to that question. Okay, so that's it. And we'll leave it there, I think, and hope that's helped.